Now, let us take a look at an example of how to draw the line of balance diagram and determine the duration of a project. We would also look at a labor resource histogram and also look at how to increase the labor in order to shorten the duration of the project. Line of balance, example 1. Construction of a reinforced concrete platform. The figure illustrates the plan and section of an elevated access platform. The work involves the construction of 6 bays of elevated deck together with the associated pile supports and capping beams. The operations are shown in the logic diagram below. Draw an LOB diagram and determine the total duration of the project. So we have the operations as install piles, which will take a 2 days duration, in situ beams, which will take a 4 days duration, and precast deck, which will take a 1 day duration. Now these are 3 different operations. Operation 1, which is install pile with a duration of 2 days, has a gang of 3 labors. Operation 2, which is in situ beams, which is of 4 days duration, has a gang of 4 carpenters. And Operation 3, precast concrete deck, is a 1 day operation with a gang of 2 labors. Let us now look at a solution to this problem. Now let us look at the solution. We will have to draw a chart on which we present the diagram. So we have a chart with the horizontal axis as the duration and the vertical axis as the number of bay. The work involves the construction of 6 bays. This means that the gang would work on these 6 bays with each bay having a duration of 2 days in terms of the installation of piles. So bay 1 will have the installation of piles taking 2 days. Bay 2 would have the installation of piles taking another 2 days. Bay 3 would have the installation of piles taking another 2 days. Bay 4, Bay 5, Bay 6 would all have the installation of piles for each bay taking a duration of 2 days each, respectively. So let's look at the first bay having a duration of 2 days, and we will show that in a red mark from 0 to 2. So it means the installation of the piles for bay 1 would start and end on the second day in terms of duration. Then from the third day to the fourth day, another bay would be worked on. So we see that the second bay had its piles installed for 2 days, moving from day 3 to 4. And we have bay 3 having its pile installed from day 5 to day 6. And we have the fourth bay being installed from day 7 to 8. And we have the fifth bay installed from day 9 to 10. And we have the sixth bay having its pile installed from day 11 to 12. So this represents a bar that is inclined at an angle with the rate of flow of work. This means that the piling operation would be carried out and end on the 12th day. But as it ends on the 12th day, the next operation would have to follow. Now, we can't allow the installation of all the piles to be completed before the next operation, which is installation of beams, will commence. Now, the installation of beams has a duration of 4 days with a gang of 4 carpenters. Now, it means for bay 1, we will have to carry out the installation of beams for 4 days, and then the bay 2 has to be done for another 4 days. The bay 3 has to be done for another 4 days. The bay 4 has to be done for another 4 days. Bay 5 has to be done for another 4 days. Bay 5 and bay 6 would each have 4 days, 4 days. When you look at this 4 by 4 by 4, the rate of operation would appear to be very slow as compared to the installation of piles. So, the buffer of 1 day would have to be left in between the first operation, which is installation of pile, and the next operation, which is the installation of beams. So the buffer we see between day 2 and 3 is mostly for flexibility purposes and for planning purposes. So we would commence the installation of beam for bay 1 from day 3. This will be done by a different group of gangs. Now, why is it so? After the installation of the piles for 2 days, the same group goes on to a different bay to start the installation of the second bay's piles. Whilst they do that, another group of carpenters would commence the installation of beams, which would start on the 3rd day. So a day is left for the installation of in situ beams, which is indicated in red. Now, it means the operation is going on. As the installation of beams is progressing, as the installation of piles is progressing, the installation of beams is also progressing. So we have our first set of beams for the B1 installed, we started from day 3 to day 7 for a duration of 4 days. And the B2 would have that also from day 8 to 11. And B3 would have also from 11 to 15. B4 would also have starting from 16 to 19. And B5 would also start from 20 to 24. Yeah, 23. And we'll have B6 commencing from 24 to 27. So we have the operation for the installation of beams having a slower rate of operation than the installation of piles. So the installation of beams will end on day 27 because the last bay started from day 23 and ends on day 27. Now, when we look at the last operation, which is the concrete deck, precast deck, with a duration of 1 day and a gang of 2 laborers, it will have a faster rate. So if we decide to bring the buffer to the bottom to start at 8, it means if it moves at a very fast rate per the days, the duration at which each bay has to be done, it will overlap the in situ beam operation. So at this point, we will start the buffer from the top, leave one clear day and start the buffer the operation on day 28. So we introduce a buffer of 1 day and have the first precast deck for bay 6 fixed between day 28 and 29. Now, this is a planning process. If we do it this way, having the last bay installed on day 28 and 29, the start of the operation would come and overlap with before the completion of the in situ beams. So we are going to come down stepwise as we plan using the line of balance. So day 5 would then be installed between day 27 and day 28, and day 4 decking will be done between day 26 and 27. Day 3 will be done between day 26 and day 25. Bay 2 will be done between day 25 and day 24. And bay 1 will be done between day 24 and day 23. So we have the last operations bar, which is completion of precast deck, in this format. Now we have the piling operation chart completed, the in situ beams bar completed, and the precast deck also completed. And at the 29, that will be the completion of the work. So this line of balance scheduling method is used mainly for activities that are repetitive. So we look at installation of piles for 6 different bays, and then the installation of beams for 6 different bays, and the installation of precast concrete deck for 6 different bays. These activities are repetitive, so if you use a set of gang to do the first work on the first day, you move the same gang to the next activity, whilst a different operation starts from what has been completed by the operation of the first activity. So this is how the line of balance looked for the 3 operations we looked at. Now let us continue and look at the labor histogram. So now let us draw the labor resource histogram. We'll first have our chart where label the horizontal axis as duration in days and the vertical axis as labor resource. We will recall from the question that the installation of piles has a labor gang of 3 and commenced from day 1 and ended on day 12 with a gang of 3. We have a resource labor histogram for piling of 3 gang labor starting from day 1 and ending on day 12, as we can see on the graph. Then we have the second operation, which used 4 carpenters, started from day 3 and ended on day 27. So we have carpenters, 4 carpenters starting on day 3. So 4 plus 3 will take us to 7. And then it started from day 3 and ends at day 27. So the in situ beam operation has been splitted so that we can completely fill all the spaces available on the graph. So piling commenced. By the 3rd day, in situ beam had commenced. By the 12th day, piling had ended, but in situ beam, which is moving at a slower rate than piling, proceeded and ended on day 27. Now, if the installation of concrete precast decking commences early, because it moves at a faster rate, it will mean that a labor will be idle for in situ beam to be completed before that 2 gang labor would finish the installation of precast deck. So the precast deck had a buffer of 1 day and commenced operation with 2 number labor from day 23. So we can see that the labor 2 added to 4 is 6 and commenced a move at par with the in situ beam on day 27 and proceed and end on day 29. This is how the labor resource histogram is constructed for line of balance. Now let us look at what we have done so far. This is the graph we had for the line of balance for operations 1, 2, and 3. And this is the labor resource histogram. Now, the operation 1 is install piles for 2 days with a gang of 3 laborers. And so we have the labor resource for piling starting from day 1 and ending on day 12. So we can see the blue line indicating where the labor resource for piling is. Then we have operation 2, which was carried out 4 days each for the 6 bays, also represented in orange color, starting from day 3 to day 27 for the operation. And when we look at the labor histogram, we see the extent to which it has reached. And then for the operation 3, which is precast concrete deck, which has 1 day duration each with a gang of 2 laborers, has a move or violet marking, took place from day 23 to day 29, which ends the project. So for 3 laborers for piling, and we had 4 carpenters for in-situ concrete, and we have 2 laborers for the decking component. Now let's continue to look at the solution if we decide to fast track this work by increasing the gang of for the operation of the installation of beams. Now we have our chart here with duration at the horizontal axis and the number of bays on the vertical axis. The operation 1, which is installation of piles with a duration of 2 days each for each bay, we have it as shown, which ends on day 12. With a buffer of 1 day, we have the second operation to commence. Now we have increased the number of gangs of carpenters by an additional gang, making 2 gangs of carpenters. So each activity or each bay is supposed to be constructed for 4 days. So when one bay is halfway through, the second gang then commences the other bay. So we have 2 gangs of carpenters, each going to work on 3 bays and then get the work completed on time. So group 1 or gang 1 starts from day 3 to day 7. Gang 2 starts from day 5 to day 9. Then gang 1 goes to day 3, bay 3, and construct from 7 to 11. And gang 2 goes to bay 4 and construct from bay 9 to 13. Gang 1 then goes to bay 5, constructs from 11 to 15, and The second gang also starts the 6th bay construct from 13 to 17. So the installation of beam is completed by the 17th day. We have a buffer at the top for operation 3, which is precast deck for 1 day. So the buffer comes, the construction of the precast deck is also completed by day 19. So we have seen that the entire operation was completed by day 19, increasing the labor for in-situ beams from 1 gang of 4 carpenters to 2 gang of carpenters will result in the completion period reducing from 29 days to 19 days. This has also increased the rate of production. So let's look at the labor resource histogram. So we have labor duration, first piling, that is 3 days up to day 12. And then we have the first gang of carpenters working from day 3 to day 15. And the second gang of carpenters of 4 laborers working from day 5 to day 17, and that is in the green hatchings. So labor resource for gang 2 as indicated in green. And then we have the last activity being the precast deck ending on day 19. So this is how the fast tracking is done for line of balance. We can see the labor resource histogram and the line of balance bars as shown.